if you could please write down 2 sine x equals 1. We are solving for x. We're solving for the degrees. So if you notice the sine x, that's going to stay together. But I do need to get rid of the 2, so I'm going to divide both sides by 2. So I have sine x equals 1/2. And what that means is kind of like the reverse of a unit circle drill. Sine of something had an answer of 1/2. So we're going to figure out what that something, what that angle was. So let's talk about this. Remember, 1/2 is a sine value. It's a y coordinate. So where do you have 1/2 for a y coordinate on the unit circle? Let me make sure. Yes, that is 30 degrees. And what's the radians? We always write them in radians. Do you have the radians in there? Yeah, it's pi over 6 for sure. So we're going to write pi over 6. But there is another quadrant where the y value is positive. Quadrant 1 and quadrant 2. What's the match for this in quadrant 2? 5 pi over 6. So that is the angle measure for sure where sine equals 1/2. And guys, we're going to focus on radians in this unit. So good job on that. All right. Any questions on number 1? Let's take a look at number 2. Let me write down number 2 with you. So number 2 is going to be sine x minus root 2. And then on the other side of the equal sign is going to be minus sine x. So sine x minus root 2 equals negative sine x. No matter what level of math class you're in, you can't solve for x when it's on both sides. So this is positive. It's going to stay where it's at. We're going to move this to the other side and make that one positive too. So I'm going to copy down the first one, which is sine x. I'm going to scoot this over right next to it, so plus sine x. Go ahead and bring down the minus root 2. And now it equals 0. Are these like terms here? They sure are. How many are there? So this is going to be 2 sine x minus root 2 equals 0. So guys, I'm going to move that root 2 over and then divide both sides by that 2. So I'm going to move the root 2 over. It's going to be positive. Divide both sides by 2. All right. So now we are looking for the angle measure where you have a y coordinate of root 2 over 2. And there's 2 answers. Quadrant 1 and quadrant 2. What are those radians? Indeed. Yep. You're going to have 2 answers. They both have a 4 in the denominator. Good. So x is going to equal pi over 4. And what is it called in quadrant 2? Yes. Remember, it's 1 less than the denominator. Excellent job. And that's it. That's why you have been taking, this is why you've been taking unit circle drills, to make this stuff not so tough. All right, example 3. Please write down 4 cosine squared x minus 3 equals 0. Okay, so this time we have a squared value. We're going to solve this like we would solve this. So we're not going to try to factor when there's just one term. We're going to move the 3 over. We're going to divide by 4. And then how do I unsquare something? Square root. And what else do we draw when we draw a square root symbol? Plus, minus, yes. All right, here we go. Move the 3 over. Divide by 4. right, here we go. So I'm going to divide. No, I'm not. I've already divided. I'm going to square root both sides. I'm going to draw my plus minus. And guys, just a reminder, I know y'all already know this, but when you square root a fraction, you can square root the numerator separately from the denominator. So when I square root the numerator, that's just square root of 3, so it's going to stay square root 3. But what's the denominator? It is 2. Good. And then look, when y'all draw the plus minus, that's all 4 quadrants. So we're going to have 4 answers here because we want all the positive and we want all the negative. Can you guys just tell me the denominator when cosine is root 3 over 2? Which one is it? 6. It's 6. And here's, guys, I memorized the unit circle based on cosine. If cosine is root 3 over 2, then these are 6's. All right, so those are the bottom. First quadrant's just pi, so easy. This one is 5 pi over 6. What's quadrant 3? 7. And then what's quadrant 4? Yeah. Nice. Okay. We're on example 4. We're almost halfway done. Super fast. Okay, so for example 4, please write down sine squared x equals 2 sine x. Sine squared x equals 2 sine x. So again, y'all cannot solve when you have x on both sides. So y'all, this is the highest degree. It's positive. I'm not messing with that at all. So I'm going to move this term to the other side, change the sign, set it equal to 0. So sine squared x minus 2 sine x equals 0. Do y'all remember what to do on this? Yeah, you factor. Good job. Great job. There's a GCF for sure. Sine x. Let's take that out. All right, so I had sine squared. I took one out. There's one left over. There was just one single sine x here. I took it out, so this is minus 2. And then remember, you set each factor equal to 0. So sine x equals 0, and then sine x minus 2 equals 0. That's already solved. We need to figure out where the y coordinate equals 0. Over here, we need to figure out sine x equals 2. Let's hold off on that one for a moment. Let's go back here. Yeah, where do you have a y coordinate of 0 on the unit circle? Where is the y coordinate? 0. Pi, 2 pi. 0 pi, yes, all three of those, pi and 0 pi and 2 pi. But remember, we're not including 2 pi. So the answer here is going to be 0 pi and pi. And then, do you guys ever have a x coordinate of just a whole number 2? So there's no answer here for us. There's nothing like that on the unit circle. Sine of 2 does exist, but not for us on the unit circle. So write NA, and the reason why is because it is beyond our domain. It certainly does exist, but it doesn't fall in between 0 pi and 2 pi. Cool. All right, example 5. So please write down 2 cosine squared x minus 3 cosine x plus 1 equals 0. So 2 cosine x minus 3 cosine x plus 1 equals 0. Y'all, that's a factoring problem. And we are going to factor this just like we would here. I'll just kind of put this in a cloud. Just like you would here. Same way. So here I go, guys. I'm going to slide and divide. Do my whole factoring thing. 2 times 1 is 2. Middle number is negative 3. I need numbers that multiply down to a positive 2, but combine up to a negative 3. That's going to be negative 1 and negative 2. I got to slide and divide. So I'm going to divide by my leading coefficient. All right. So my first factor based on this side, this is going to be 2 cosine x minus 1. My other factor based on this side is going to be cosine x minus 1. And then I'm going to set those equal to 0 and solve for x. Okay, so we just need to figure out the radians on the unit circle where cosine equals a positive 2, which is going to be to the right of the origin. And then also where cosine equals positive 1. All right. Do y'all know the radians for this one? 1/2. Pi over 3. Yes. But that's not the only one. That's quadrant 2, but x is negative in quadrant 2. There's another quadrant where 5 pi over 3. Quadrant 4. Very good. Yes, yes, yes. There's only one answer here. Where does it equal? 0 pi. Yeah, 0 pi and 2 pi, but no 2 pi today. So just 0 pi. Yes. Okay, these are baby problems. Let me show you something more like our level. 2 more to go, y'all. Example 5 and example 6 and example 7. For example 7, please write down 3 secant squared x minus 2 tangent squared x minus 4 equals 0. And then, just like I couldn't factor mixed trig problems, I can't solve mixed trig problems. But if you notice, both of these are squared, which means your identities are definitely going to be used over here. This is one of those ITAN secretly identities. So I'm going to leave it in terms of secant because I want us to practice reciprocals. So I'm going to use substitution for that right there. Y'all, what does tangent squared x equal? Secant squared x minus 1. All right, here we go. So I'm going to recopy the front. I'm not messing with the front. So 3 secant squared x, even the minus 2, and then boom. Right here I'm dropping in secant squared x minus 1. Then I'm going to bring down minus 4 equals 0. And y'all, we're going to have to distribute twice. You're going to have to distribute to the secant squared x and also that negative 1. All right, here we go. Still just bringing down the front, didn't mess with it. Negative 2 times secant squared x is negative 2 secant squared x. And negative 2 times negative 1 is positive 2. And then bringing the rest down. All right, cool. Look, I can combine the 2 and the 4, but is that all I can combine? Are these alike? Yeah, same trig function, same exponent. So we've got some cleaning up to do. So 3 secant squared x minus 2 secant squared x is plain secant squared x. A positive 2 minus 4 is negative 2 equals 0. Okay, I'm moving that 2 over. I'm square rooting both sides. I'm drawing a plus minus. So secant squared x equals, oh, no it doesn't. It equals 2. That equals a 2. I'm going to square root both sides. Is 2 a perfect square? No, it's not. So plain secant of x is going to equal positive negative root 2. All right, so y'all, first of all, it's positive and negative. We know we're going to have 4 answers for all 4 quadrants. And then do you remember what this is the reciprocal of? It's root 2 over 2. So we're just going to write the radians for root 2 over 2 because it's the same. What is the denominator for the answer on these? 4. And it's all of them. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Yes, yes, yes. Final example. So y'all, this is like a day 2. But I'm having a point across here, so please write this down. All right, example 7. Please write secant theta. We work with theta. Secant theta equals sine squared theta times secant theta. So just put another secant theta right next to it, just like that. It looks really loaded and really heavy. Just remember, sometimes this stuff, to us, we've got this because we understand how to just solve for a variable, guys. It is the same thing. I can divide by the same thing. These secants cancel out to a 1. Those secants cancel out to a 1. And then what would you do from there? Square root both sides. One's a perfect square. So we need the sine value for theta, where it equals a positive 1 and a negative 1. What does theta equal? Yeah. Just the top and the bottom. Yep, that's right. It's pi over 2 and 3 pi over 2. Great job. Okay, so